Now let me just revise and compare all these quantities. Like a resistor, which is given by this symbol, which you are aware of, it has a property which is called resistance. Okay, and this resistance is given by a symbol R. Okay, and if the current through this resistor is I, then the potential drop in a resistor is IR if it has a resistance of R. In a similar manner, if you have two plates, metallic plates, one is positively charged and one is negatively charged, then it is called a capacitor, and it has capacitance. Capacitance is given by C, and the potential drop delta V in a capacitor is given by Q upon C, the charge on this plates divided by the capacitance of the capacitor. Okay. In the similar manner, the inductor is a solenoid. Like a capacitor is two metal plates and they are oppositely charged, they are very close together, then it is called a capacitor. In the similar manner, a solenoid used in a circuit is called an inductor. Okay. And it is given by a symbol L, and the potential drop in an inductor is given by L di upon dt. We can also calculate this, and we need not learn it. Let us say that the current is flowing in this direction, and the number of turns in the inductor is, or the solenoid is N, and it has a length of L. Okay. So now if the current will increase, the magnetic field inside the solenoid will increase. So let's say that the current is flowing in this direction, so the magnetic field will be, this should be the direction of the magnetic field. Okay, and therefore the magnetic field will increase, magnetic flux will increase. It will give rise to an EMF which will try to oppose this current. So this will act like a battery. Inductor will not allow this current to flow, and so the current is flowing, initial current is flowing in this direction, and it will act like a battery which has a potential drop of epsilon. Okay, so this epsilon, it will try to oppose this current, and this epsilon will be given by minus n d phi b upon dt. This is from the Faraday's law. So let's put the values of flux. Now flux is given by B into A cosine of theta. Theta will be 0 in this case because area vector and magnetic field vector, they will be in the same direction. Area is this cross-sectional area. Okay. So then it will be B into A. Now this is a simple solenoid. So in a solenoid, the magnetic field is given by mu naught n I into A. And what is small n? It can also be written as mu naught n upon L I into A. The small n is number of turns per unit length. So then epsilon will be given by minus n d upon dt of phi. So phi is this, so it will be mu naught n I upon L into A. So now in this, you know that mu naught is a constant, n is a constant, L is a constant, A is a constant. So the only variable is, what is changing is current, okay, here, because the current is increasing or decreasing. Rest everything else is a constant. So this equation turns out to be mu naught m square A upon L di upon dt. This will be epsilon. And this quantity, it will be minus L di upon dt. That is why we say that the potential drop in an inductor will be minus L di upon dt. Okay. So this L is called the inductance of